So responsive layout grid has these concepts that we need to understand in order to implement them. We will be going through each of them now, and then in the next session we will go through the patterns involved in implementing responsive layout. So in this session we are going to focus on these concepts. So let's take a look at pixel density. So pixel density, what is pixel density? So pixel density means that the number of pixels tightly packed in a space. So typically we use notation like a DP or DIP, which simply means density independent pixels. DP is a unit that is also called as different names on different platforms. For example, on web you would call it as logical pixels, and iOS it is called as points, and Android it is called as DP. The actual pixel size is much smaller, and you are tightly packing them and calling one logical unit which may contain more than one pixel. And there is another term called DPI or PPI, which means dots per inch or pixels per inch, which simply means that in 1 inch how many pixels have been packed. So by using the unit as DP inside your app, you would have the UI elements look as same screen size irrespective of the screen density. So here on the left hand side we have a low density screen, and here we have a high density screen with more pixels packed in the same space. But if you look at this floating action button in the circular shape, it would appear as same size on both the screens. And what are the other things that we need to know about DP or the logical pixels? So here I have some examples to explain it better. So we have some devices like Nexus 10 that is containing a width of 1280 dp and a height of 800 dp. So which means its logical resolution is 1280 by 800, whereas its real resolution is actually 2560 pixels width and 600 pixels height. So which means we have a density of 2 pixels per 1 dp or 1 logical pixel. Okay. So similarly for iPhone 6 Plus, you have 3 pixels for 1 logical pixel or 1 dp. So the real resolution is 1080 by 1920 pixels, whereas the logical resolution is 414 by 736 for iPhone 6 Plus. So the screen sizes can change, but every screen size will be always be resolved into a logical resolution, and we will always define the sizes in your app using the logical pixels, so that they will fit the logical resolution, which will ultimately result in the real resolution. So that the images or the sizes of the views, they would all appear uniformly on screens of different density. Next, on our responsive layout grid, we have a few things like columns, gutters, and margins. Let's take a quick look at them. Columns is nothing but how many number of columns that we are dividing our layout with. So this is typically useful as a notation to understand. So if you have a small screen, large screen, and a medium screen, and material design guidelines tell us some recommended number of columns to use. For example, here a 360 dp screen is recommended to have 4 columns, whereas a 600 dp size screen is recommended to have an 8 columns size. So you are actually dividing the screen into number of columns based on the screen size. And then gutters are nothing but the space between the columns. So this is a 4 column screen, and we have the gutter of a size of 16 dp or 16 logical pixels, whereas on the tablet you have a 24 dp gutters, and this is of course at 8 columns. Similarly, margins are the ones at the border of your views, and this margin space, as you can see here, on a 4-column grid you will go with a 16 dp margin, and on a tablet size or a medium size screen it is recommended to have a 24 dp margin. And also, it is not necessary that you should always have bigger gutters or a fixed gutter for each screen size. For example, here you can customize the grid layout with a small gutter. So here, even though this is a medium size screen, the gutter is only 8 dp. This is to indicate that, so my album here has pictures, and all these pictures are closely related, and they all belong to one single album called my album. Whereas here I am displaying a list of albums, and to indicate all these albums are individual entities, you can have a larger gutter between them. And when it comes to margin, depending on what you're building, here I have small margin so that I can have more space for these closely related images. Whereas here I have a larger margin to provide a good reading experience. And when it comes to the grid size itself, you can have these columns. Since we are dividing the grid into a number of columns, for fluid grid, you can have these columns expand to the screen size. So if you are at if the screen size is medium, you can have the columns expanded. Whereas under fixed grid, the behavior is that you can have the size of the columns fixed, the size of the grid fixed, and the margin is expanded. Uh, and this is really like a preference, and you can decide what to go for, fluid grid or fixed grid, depending on what you are building. Breakpoints are quite useful to determine at which point we should switch from one layout to another layout. So we use the screen width as a factor and identify when the screen width reaches a certain breakpoint range, we switch from one layout to another layout. So here we have the breakpoint ranges. So material design recommends 600 dp as the first breakpoint. So anything below 600 dp, we will implement it as a small layout. So any screen size that falls below 600 dp will always result in this same layout. And for any screen width between 600 to 839 dp, we will define a medium layout. For anything above 840, we will define a large layout structure. So we have three different layouts that will work for three different breakpoint ranges. So this is the first breakpoint range, this is the second range, and this is the third range. So here we have like a detailed guideline. You can check out the material.io website, this table, to understand it more better. But the gist of it is that you can have the grid as containing 4 columns for a small layout, and 8-column grid for a, you can divide your medium screen into a 8-column grid, and your large screen into a 12-column grid. And at the point at which you are going to switch between the small layout to medium layout is 600 dp, and from medium to large layout is the 840 dp. So we are going to define usually 3 layouts and adjust the layout structure and we will apply the responsive patterns that we will learn in the next session to provide a great user experience for each layout size. So, to summarize what we learned in this session, we looked at what kind of problem a non-responsive design will result in, and how to better design using responsive design principles. And we are actually going with Google's material design guide because it is solid and covers many scenarios. So under material design guide, one of the fundamental concept is responsive layout grid, which is an imaginary grid that we are going to divide our screen into. The grid itself will contain a number of columns, and the grid is going to have margins and gutters, and pixel density is used to declare uniform sizes across multiple screen densities. And you can also have the grid itself customized with slightly larger or smaller gutters and margins. You can have a fixed grid or a fluid grid, and finally breakpoints, which will tell us when to switch our layout between the small to medium or medium to large, or vice versa. In the next session, we will learn about responsive design patterns and use them to arrange UI components within a small layout, medium layout, and a large layout.